The first question is that we know fx equals to u of fx minus 1 minus u x minus 2, and fy equals to u of y minus u of y minus 1. So we all know that fz equals to fz multiply fy of z, and which equals to integral of fx a multiply fy z minus a multiply the division of a. So we can write this formula equals to the integral of u of a minus 1 minus u of a minus 2 multiply u of z minus a minus u of u of z minus a minus 1, and multiply the variation of a. Then I write our separately, which equals to the integral of u of a minus 1 multiply u of z minus a minus u of a minus 1 multiply u of z minus a minus 1 minus u of a minus 2 multiply u of z minus a 8 and u of a minus 2 multiply u of z minus a minus 1, and then I can calculate directly. The first part equals to integral of u of a minus 1 multiply u of z minus a and multiply the variation of a, because a minus 1 must larger than 0, and z minus a must larger than 0, so we can get out that a is between 1 and 0, so z must larger than 0, so we can write this equals to integrate from 1 to z of u a minus 1 multiply u z minus a multiply division of a, and multiply u z. The second part is that integral of u of a minus 1 multiply u minus a minus 1 multiply derivation of a, because a minus 1 larger than 0 and z minus a minus 1 larger than 0, so we can get a is between 1 and z minus 1, so z minus 1 must larger than 0, so z is larger than 1. And the third part, we all know that is integral of u of a minus 2 multiply z u of z minus a multiply derivation of a, so a minus 2 larger than 0, and a is larger than 2, so we can get a is larger than 2 and less than z. so z must larger than 2. So we can get try to get the third part, the last part. For this formula, a minus 2 must larger than 0, and z minus a minus 1 must larger than 0 too. So a is between 2 and z minus 1. So I can write all this together to get this formula, and then I can calculate that it equals to z multiply uz minus z minus 1 multiply u of z minus 1 minus minus z minus 1 multiply u of z minus 1 and plus z minus 2 multiply u of z to z minus 2. And the second mention is that we can use pictures to get the answer. To begin with, because fz equals to fz of x plus y less than z. So when z less than 1, fz equals to half of z to the power of 2. So we can make diversion of fz, and so when to get fz equals to z, and when z larger than 1 and less than 2, we can also use some method to get that equals to minus z to the power of 2 over 2, and plus 2z minus 1. So fz equals to minus z minus 2. So we can get the graph of that and get the answer. It equals to z multiplied uz minus z multiplied uz minus 1 minus z minus 2 multiply u of z minus 1 minus z minus 2 multiply u of z minus 2. That's all. Second question is that fx equals to 1 over a multiply y squared and multiply x. Y is larger than 1 and x is between 1 over y and y. And we can draw a picture of that and get the shortened area to the range. And the second question is that because to find a so that fx is a valued joint determinative function, so we all know that fxy equals to 1. So we can make double detonate to that formula to get the answer. It equals to 1 over a the identity from 1 to infinity, and identity from 1 over y to y of 1 over y squared multiply x and multiply derivation of x and derivation of y. And after 7 steps, we can get it to that it equals to 2 over a multiplies the minus 1 equals to 1, so we can get answer that a equals to 2. And to third question, we must find and draw the Magriano determinative functions fx and fy. Fy equals to integrate from 1 over y to y of 1 over 2 multiply y squared and x multiply derivation of x, so we can get the answer and y over y squared, and the range is y between 1 and infinity, so we can draw a picture of that. And fx fy of x equals to integrate from 1 to infinity of 1 over 2 y squared multiply x and multiply derivation of x of y, so it equals to minus 1 over 2 x squared. And I can also draw a picture of that. The last part of the question is that we must verify fx and fy are valid determinative functions. So we can make integrate from 1 to infinity of fx and fy. They all equals to 1, so it's verified.